Ladies and gentlemen, welcome to my shop. Welcome to my channel. My name is Keith and I'm your host. Before we get started, class, how about the Pledge of Allegiance?
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Peace! Peace! Amen.
All right, I'm getting ready to change this end for end. We well built this trunnion diameter here, and we want to go ahead and build the one on the other side. This setup in the weld position are pretty nice, and running it this way lets us have some pretty good control on getting that built up in the rough shape. And we have the cap in here, we kind of just like eyeballing it. We built up the diameter on the inside, and then after that then we went around the outside of the two larger bosses to create the diameter over what we wanted. We want more material. It's better to be looking at it than looking for it. All right, so we're going to endo this. These diameters are pretty close. We're not really dialing in our forejaw. We are looking at the lines on our chuck, and we're just kind of eyeballing its center. All right, I like that. All right, now we can put this, we'll just run this a little bit farther in here. The other one, we had that ear where the bolt goes in here for the wheel, and that was really, really close. So, all right, and we got this block here because it helps us hold our hand real steady. All right, the first thing we do is we're going to go ahead and wire wheel the finish on the outside of this. And that's just removing all the oxidization on the outside of it. Now we can bring in our TIG torch, fire off our welder, and build this up like we did the other side. Okay, the first thing I'm going to do is run lineal beads this way here, and we're going to fill that small diameter until we're flush with this outside diameter that we've turned on the OD of these to be true with the rest of the axis. Okay, and we're just going to start here, and we're going to just slowly, one pass at a time, making sure that we have enough penetration right into the root, right along the bottom, right over to the other side. It's going to take multiple passes around. This is just 70S TIG wire, 1/16 that I'm using to feed this. I'm only running about 100 amps on it, and I'm controlling it with my foot pedal. We just finished making it once around, where we just start establishing new material mixed on, penetrating with the base material. All right, now we're just going to go ahead and we're going to do another pass right on over the same as we just did. All right, we nearly filled this in now with our second pass. And we're going to go ahead and we're going to put a third pass across here because we want this to be at least this height here before we go ahead and bring the outer bands here and here. All right, we're ready now to go ahead and put, it's about 4 beads, just like we did on the other side. One real close, one out here, one on top, one up there. So it's like 2 beads stacked too high. Same thing out here. Okay, we've got our 4 passes right here. Now we're going to do the same thing out here at this end here. Okay, I'm pretty sure that I have more than enough on both of these trunnion pivots. I'm going to let that cool down, and it's going to be ready to go into the lathe. We brought this in, got it in the lathe, and we chucked up on that end, leaving the rope pulley side over here because of this ear here. And this is the first one we wanted to set up and slide this into place here. And our rollers are not making it onto this boss, and we're hitting there, and these rollers are just getting on our surface. So the steady rest, our steady rest, without doing any modification and without turning things around and making a big project out of getting these rollers in on this surface here and having clearance on this, it looks like we're gonna set that off to the side. We're gonna come in here and we're gonna support it and do our machining right from the center. All right, now we need to know is how good that, or how well that center stayed true with our machining after all that welding. And here we go. Here's our okay, there we go. We're locked in there now. Okay, let's come down on the low, set it at 0, and coming up, we got like 4.5 thousandths that's running out. All right, that's actually pretty close. And I think I can somewhat manipulate this center hole here to offset a couple thousandths. If I get that to offset for 2 thousandths, I can get this to run really true. I could run it right now. Who's gonna this 4 thousandths total run out is only 2 thousandths off center. This can run 2 thousandths off center because the bell only turns like this, and this distance between there and the clearance we're going to have is going to be well within acceptable operation. But let's just say that this wasn't, and we wanted to make this as close as possible. How would you modify that center right there? And an old timer showed me how to scrape a center. So we're going to take the center drill, we're going to put it in a little handheld chuck, and we're going to scrape the side that is pushing away, so that will offset, it will egg shape somewhat the center, but we'll egg it to our advantage off on the side we need to relieve the material. Alrighty, there's our high. Okay, so it's being held over this way here, so we want to cut on this side so that it'll open up the side of the center drill on this side and let the shaft move on over to the other side. Alright, so we'll go ahead and we'll back this off here. And we're going to put our number 4 center drill in here. And I'm taking it and I'm scraping on my side of that center drill. Okay. Bring this back in. Okay, and we did lessen it. We're about 3 thousandths right now. All right, let's see if we can scrape just a little bit more. If we get another thou out of here, so I'm gonna let it go. But this is good practice. Just sometimes you might have a shaft that you have just a thou or so that you need to adjust it, and you can do that on your center. All right, we're running within 1 thousandths right now. We're going to let that go. All right, we're basically going to do exactly the same thing as we did cleaning it up. And we're going to start and we're going to skim these 2 diameters right here to size. I'm going to touch off on this outside one here, and I'm going to set my dial to 0. Here we're just comparing that diameter with the inside diameter. And we're about 20 thousandths smaller on that one there. So we're going to come back out here. There we're touching again. And we're going to go ahead and we're going to take 30, which should clean up, not clean up, it should be touching both surfaces. Now, we are going to run our cutting oils on the surfaces here just to help out. Not that we're going greatly fast and we're going to be smoking a lot of chips off of here. We're going to try to hold it down to a speed and control that we're not developing vibrations, harmonics, and other problem surface conditions that you can run into by having something extended out this far. Okay, now we're just going to bring it over here to the other side by hand. Okay, we're touching there. Okay, we're going to set 0 on our travel dial right there, even though we know we're not kind of touching that edge there. We're close to it. Okay, I'm just taking another 20 per side. Pretty easy chip coming off of that. We're cutting around enough to get a micrometer on that and find out what size we are at. Not too bad on that finish. I see a little bit of herringbone is what I call the pattern. You know, it's very, very minor, but it has some. Okay, let's see what we got here. 1 inch 190. Within a half a thousandths there. This diameter here, I scale the opening on the yoke over there, the support, and it's just under 1 inch 200, and it's wallered out real thin. I'm proposing to make those diameters 1.125", which were pretty close to what I thought they were before I started weld building these diameters here. So we've got about 50 thousandths plus a little bit to take off of this diameter here. All right, I'm 4 thousandths over 1.125 inches, so 1 inch 129 thousandths. All right, from this face out, I want to be about 1/4 inch, because that's about where we're going to be flush out here, and that's what they had in here for a space or clearance between the inside of the bell. And then this area right here was holding this outside surface here. This is the surface that's really worn, and this is about 1 inch 200 across here. But we're going to braze this on in here, and that's where we're going to bring it down close to the 1.125" with just a little clearance, because this surface right here is the surface that it needs to be bearing by. All right, so what we're going to do is we're going to touch that base, come out, and we're going to take our tool bit and let ourselves have a visual of that 1/4 inch out, plus a couple thousandths, just to be, so we always have some room to clean up on. And then we're gonna start working on that middle section right there. Okay, that's our 0 right there. So we're going to come out 250 plus 25 right there, just to be on the safe side right there. Okay. Now we can come in until we just start skipping this diameter here. And now I'm feeding in. I'm doing this without any cutting oil so I can really see where I'm at. Of course, I have my travel dial also set. Okay, and there's our 0. Now we can feed outward. Of course, we're going to be cutting on the back side of that D&MP, but we know that that width in there is going to be about 900. All right, we're just holding it up there. We want to scale this. So that's about 900 in there. It's pretty darn close right now. All right, we're going to change this bit out with our parting tool, because we're going to come in and we're going to work that center section down close to size with our parting tool. This diameter here is about 1 inch 50 thousandths, 59, 58, somewhere around in there. So it's just about 1 inch and a 1/16. Now we're somewhat just inside our turn diameter that we brought that out, and we scaled it, and we set our tool bit at that line and came back over here, and there's plenty of room out here to kiss off. There was 300 thousandths out here on this outside by our measurement of this depth here. We want a little braze on this diameter here. We may make this slightly wider in here. Alright, we're going to go ahead and see how this thing plunges. Okay, we're going to set it at 0 there. It's doing a little moving around. We'll move it on over. We'll work another area here. We may have to shorten up that blade so it's more stout. Bring it back so we're not sticking out so far. Alright, we shrunk it up some. Looks a little better. We're just going to try to take a little bit at a time here. Try to get it down to smooth material. Let's measure what diameter we turned into there, and we got like 924, 925. Okay, we're just plunging in. I got it clear out so I can actually see what I'm doing here. We're taking a little section at a time, and we're just parting into it. We're at about 924, 925. We need to come into 3/4 inch, but we're just taking a little bit at a time. Alright, there's 30 thousandths on the depth. Now we come out, we come over about the width of our parting tool. We'll come back into our 30 thousandths, the same. Right there. And we come over again. And one more time. Then we'll put our D&MP in there and we'll take it over to the other side. And then come back and forth and work both a right and left hand D&MP. Okay, this diameter now we got it down to about 7. I'm just having to stick my head in here. It's about 787. So we got about 30 thousandths on that diameter. So I'm going to go ahead and reach in here with my D&MP, and we're going to take this diameter down to that depth or the length of that shoulder that we want right there, so we can get rid of most of that material right there. My buildup really looks solid, which I kind of felt that when I was adding the material on there in the weld positioner. It was giving me a good sense when it was filling in. I wasn't having any issues with it. Okay, we're gonna bring it all to there, and then we'll face that shoulder off to distance when we get closer. Alright, now we're just going to come in till we touch. There we go. Okay, the last thing we're going to do is come in here and just break these outside corners just a tiny bit. And then this one here is open air, so it just kind of like, we just want to make sure it's, there we go. All right, we're going to hit that with a little bit of emery paper. We just removed our bolts for the counterweight. And we grabbed our wheel. Now, I don't know why, but I think when my customer brought this in or whatever, we were trying to put this on in this direction, and the lock bolt here kind of more so lines up with the keeper, the dimple in the shaft. But after looking at this and doing these and then coming and putting the support foot in here, the support foot in here would be hitting the outside of this wheel in this position. And so I turn it around, and this is actually just a little bit longer than that recess, and this doesn't quite line up with the dimple, but this sits perfectly with the lockdown now, which didn't make sense with it sticking out and having a gap in here. All right, so we have everything on the yoke completed. This is a good diameter right now, so we're going to leave this as is, and we're going to skim the bore to clean this bore on the wheel, and we're going to clean up this surface all the way around this locking screw or the dimple screw here, and we're going to braze it up, remachine it so that it slips on here properly, and then we will go ahead and come down and make this a new dimple resting spot, because there's not 100% way that we can come in here and make it line up with something that doesn't line up to start with. And we have a new bolt that we're manufacturing for this lock here. And then this wheel will 100% match this yoke. Whether this actually went on this yoke or not, or something was done in the past where it doesn't really jive, the machine marks do not tell the story that this actually was a correct match. All right, let's go into the K&T. Okay, I think we're set and ready to bore that out. Looks like it's got a lot of clearance. Okay, now we have preset our cutter in here. I don't know if we're going to have to find center here. Kind of guessing on that. All right. Looking pretty good. Okay, we're going to get some power and we'll get this set up and get you in position to watch the cut. Bye.